Hey everybody, hope you're doing well. I'm just going to give you a quick tutorial here on how to use the TI-Inspire for some of our statistical calculations. The eMath instruction video uses, I think it's a TI-84. The help videos in Delta Math are also using an 84, so this will give you an idea how to use the TI-Inspire for these calculations. And then I'll also show you, if you don't happen to have your TI-Inspire with you at home, how to use the Delta Math resources to do the same calculations. All right, so let's get into it. So I just pulled up here a problem in Delta Math just to get a sample set of data. All right, so I'm just going to enter this data into my TI-Inspire. So in order to do that, I go to the home screen, and then I'm going to go to a new document. So I'll get one for new document, and then I want to add list and spreadsheet. So add list and spreadsheet. And then once you're here, up here, you can title this whatever you want. I might just call it, for this example, data. And then I'm just going to go ahead and enter in these values right over here. So this is 68, 58. If you want to pause the video to enter those into your calculator, that's fine. I'll just kind of quickly go through here. I'm not going to read them all out loud to bore you. But go ahead and get those entered in. One thing that you want to make sure is that you've got them entered in accurately. You haven't missed any values as you go. All right, so the question over here says population standard deviation. That's what they want us to find. The eMath video is going to give you more of an understanding of what that is. This is just going to kind of give you the keystrokes so that as you go through that video, I would suggest pausing it to enter in and practice using the TI-Inspire so that you have a better understanding of what he's doing, since he's using a different calculator. So this is designed to help you with that. All right, so the next step then is, once we've got that entered in, and I always like to find cell 1 and then move to an open space over here. A common mistake is to see the cursor as you're going to enter something in, but you want this cell to be highlighted blue. And we're going to go Menu, Statistics, Stat Calculations, and then we're going to do a one variable stat calculation. Our number of lists here is 1, so I'll hit OK. And then this X1 list, that's what we named it, which was data. So I'm going to select data, and then there's just the one list, so I'm going to hit OK. And then you'll notice over here it populates all this information for you. So if I just kind of click over, this is saying, hey, we did a one variable stat calculation. X bar, so this right here, this value is the mean. So if the question over here would have said find the mean of the set of data, right here, X bar, that's the mean, that's the average. And then if I scroll down a little bit, these are the representations for standard deviation. S is going to represent the sample, and then our Greek letter here is going to represent the population. So the difference between the two is a sample, meaning it's just part of the set of the data. If you're asked about the population standard deviation, that is the entire set of data. So in this case over here, our question says, or asks for the population standard deviation. So I'm going to choose this value, and then notice it says to the nearest hundredth. If you need to click on this, down here will show you everything that you need in terms of decimals. So here's tenth, hundredth, that's a 0 here, so it's going to be a 10.35. So I'll scroll over here, and then I'll be able to go with 10.35. I'll submit that answer. Yes, looks good. So that's kind of how you can accomplish that as you're going through the Delta Math assignment. This one variable stat calculation also gives you some other useful information, and part of your Delta Math homework is going to be recognizing what these values mean. So if I gave you some calculator data, such as this set of one variable data, could you tell me that the mean is 54? Would you be able to look at that and know that the sample standard deviation is 11.18, or whatever it needs to be rounded, whether it's tenth, hundredth, if it's tens, hundreds, thousandths, that this is the population. So that is, all the data for your experiment or whatever it was, your survey, your study, and you're using all the data that you have to make this calculation. That's when you would use this representation for the population. N right here, N is just representative of 7. That was how many values we had entered in. 1, 2, 3, 4, 5, 6, 7 data values. So that's what that tells you. As I keep moving down, it's going to tell you the minimum value is 41. Here's quartile 1. So last week when you did some work with quartiles, you'll notice here's quartile 1, which is 46. Here's the median, which is the essentially quartile 2 value. Here's quartile 3, and then there's our maximum value. So if you needed to quickly find your interquartile range, 68 minus 46, there's my interquartile range. If you needed the range in general, I could take 69 minus 41. That gives me the range of the set of data. So I could find the range, the interquartile range. I can find standard deviations. And this also tells me what the average is. So that's a useful part of this type of a data description here. All right. Now let's say, for instance, that you didn't have your TInspire with you. And so if we wanted to try another problem like this, here's how you can use just with the tools within Delta Math to be able to answer the questions. Works out pretty nice. I'm going to click to copy values for calculator, and then I'm going to open the stats calculator. It's going to take me to this new sheet. And then this main menu up here, it says edit lists. I just want to paste the values and it automatically puts them in there for you, which is kind of nice. And then up here, I'm going to go to calc menu. And what I want to do then is a one variable stat calculation. So I'll select list 1. There it is. I only had one set of data, so then I'm going to go ahead and click on calculate. All right. And then here it's going to show you the same type of thing as what we just saw on our graphing calculator. Here's your average. All right, here's your sample standard deviation. Here's the population standard deviation. We had 7 data values. The minimum was 39. The maximum was 58. Here's quartile 1. Here's quartile 3. There's your median, the middle value. And so that's how we can interpret that. So then if we look back at the question that it asked us here, it's sample standard deviation in this case. So our sample standard deviation value is 7.57. Let me just make sure I've got that rounded to the nearest hundredth. Yep, 7.57. And there we go. All right, so it just kind of takes you through what to do if it's a one variable stat calculation. Okay, the next thing that I want to show you here is in Delta Math. You may encounter a problem here that talks about finding the population standard deviation when you're given a frequency table. All right, so frequency tables, if you remember from last week, you're looking at the value of 10 that occurs 4 times. So what we're saying there is that I could have in this set of data a 10, a 10, a 10, and another 10. There's 4 10s, and I could write it out. 4 27s, 27, 27, 27, 27. There's a 28, there's a 32, there's a 34 and a 34. There's 6 45s listed out here, and there's 4 46s. That's what the frequency table does for us. Okay, it just tells us how many times those specific values are going to occur in the set of data. All right, so here's how we handle that if we're doing a one variable stat calculation. So I'm going to go to go home here. I'm going to go new document again. If it asks you about saving, you don't have to save anything. Once again, I'm going to go to list and spreadsheet. And up here, I might start with just calling that column data. And I'm going to go ahead and enter these values in. So 10, 27, 28, 32, 34, 45, and 46. So I just entered those values. And then this second column, this is a little bit different here. I'm going to put the frequencies. So how many times did 10 occur? That occurred 4 times in this set of data. 27 was 4 times, and a 1, 1, 2, 6, and 4. So now I have not just the data values, but the number of times those occurred represented as the frequencies. And then just like we did before, remember you don't want to be selected as a cursor. You want to have a light blue box highlighted here outside of the two columns. So over here to the right, I always like to find that spot. It works real well for me. And I'm going to go menu, statistics. I'm doing the same stat calculation and then one variable statistics. I have a one set of data, and my set of data I called data. Now here it says frequency list. We called our frequencies frequency there. I just shortened it to FREQ, but I have to make sure that I enter that in so that it accounts for the data being more represented more than just a 10, a 27, a 28, a 32, a 34, a 45, and a 46. It has to account for the repetition. I'm going to hit OK, and it's going to produce a similar looking stats calculation here. There's my mean. I scroll down a little bit. Here's my sample standard deviation. There's my population standard deviation. This number of values is 22. So think about that. 4, 8, 9, 10, 12, 18, 22 values. So that's where this 22 comes from. Once we've gone through and done the frequencies, there's 22 values. The minimum value there is 10. Quartile 1 would be 27. Remember, that's 25% of the data would be less than 27. 34 is the middle, so 50% is less than 34. 50% of the data is more than 34. Here's quartile 3 is 45. That means 25% of the data is larger than 45, or 75% of the data is below 45, and then our maximum value is 46. All right, so we can still do the same type of calculation using the TInspire if they give us a frequency table as we could otherwise. This asks for the population standard deviation. So if I scroll up here, here's my population standard deviation to the nearest thousandth. So 10th, 100th, 1000th. If I've clicked on it, 10th, 100th, 1000th, I think is going to give us 13. What's that? 0.190 is to the nearest thousandth. All right, now if you don't happen to have your TInspire, I'll take you through that process here with Delta Math. I'm just going to make it a little bit larger for us here. So you can come down here and click on Copy Values for Calculator, and then Open Stats Calculator. Once you've done that, go ahead and click Paste Values. Automatically will fill in everything that you need. So that's kind of quick and handy. I'm going to go to Calc menu, and then I'm going to choose that one variable stat calculation. The list of data was in L1, and then the frequency list was in L2. And then I'll click Calculate, and you'll notice it should produce the same set of values as what our TInspire produced right over here for the same calculation. There's our mean, and you can see it matches with X bar. Here's our sample standard deviation, and down here that decimal is expanded out, and that's what you see here. Scroll down just a little further. Here's our population standard deviation, which you're seeing. We see that the number of values was 22. And then once again, scroll down, there's your min, quartile 1, median, quartile 3, and your maximum. And that all corresponds right over here. So the question was the population standard deviation to the nearest thousandth. So population standard deviation to the nearest thousandth, 10th. 100th, 1000th is 6, causes that to round up. So 13.190 is what I'm going to enter in here. 13.190. And it looks like went pretty well there. All right, so this is just a video to kind of get you started. The eMath instruction video to follow will give you a greater depth on standard deviation, but make sure you come back and reference this if necessary to help you out.